My name is Hemant Jayaraman. I'm from Rent-A-Center, and speaking along with me is Arthur Suleiman from Flex7. For those of who you're new, Rent-A-Center is rent-to-own. We're in the rent-to-own business. We have about 3,000 stores throughout the country, dealing with furniture, appliances, and computers. And Arthur Suleiman, he's the CEO of Flex7, based out of Austin, Texas, and they're an Amazon partner. And before I get started, I do want to give a shout out to a large team of both Rent-A-Center and Flex7, without whom this would not have been possible. And countless hours and days and nights, they work to make this happen. Before I go into details on the overall design and architecture, we wanted to give you an outline on the DevOps evolution at Rent-A-Center and how that came about into the e-commerce business case and how that evolved into some of the outcomes that we wanted to achieve. And Arthur will go into more of the design and architecture of the actual SAP Hybris implementation. So when we started DevOps at Rent-A-Center, it was in 2015. There are different schools of thought on how to enable DevOps at any company. There's one school of thought which says you have to have have the DevOps philosophies built in across IT on day one. There's another school of thought which says, hey, you build a core DevOps center of excellence and then use that to get the DevOps philosophy across the organization. We did the latter. There is no right or wrong answer. I think it varies with different organization, the maturity model in agile practices. In our case, we started the DevOps COE early in 2015. That evolved into the first project at AWS called our WAN project, which is part of our Acceptance Now business unit. And then somewhere in middle of 2015, we also launched our first as-a-service implementation inside the company, which we offered our Elk Stack as a service. So, and then because of the maturity we gained there, late 2015, early 2016, we had a very aggressive target to build our complete e-commerce solution, including all the back-end integration, in a very short span of 6 months. So that's where we'll go into some of the lessons learned on how we built upon some of the successes earlier on. And later this year, we're also going through some of the Oracle RDS migration from an on-premise to RDS instance in the cloud. And as we look forward to 2017, our goal is to go further evolve into serverless computing. So as just a brief overview on the first project we built at AWS was for our Acceptance Now business unit, a B2B portal which will enable our partners, and there was a lot of PII and PCI data involved. So we had to build an architecture which will support all of the industry controls and audits that go with any kind of data that we carry. So we had to build security as a core focus in everything we build. And we started off with basic using least privilege access and things like encryption at rest and encryption at motion. And of course, availability is also one of the very key components, including multi-region capability and auto-scaling. And this is for the first time early last year when we finished the infrastructure as code. So this is the first time we actually use CloudFormation templates to help build the complete infrastructure for the WAN project. And we also started using Ansible playbooks for our post-deployment automation. That then resulted in the next need for the business. As we were going through a digital transformation, the business wanted a complete 360-degree view of the customer and also be able to enable some self-service capabilities, and ability for customers to rent online for the very first time. So in order to achieve some of these business goals, we selected SAP Hybris as a platform of choice. And for those who are not very familiar with SAP Hybris, it is a stateful application. So we had to take a stateful application and make it stateless. So a lot of the explanations which Arthur will go into are how do you take some of those applications where there is a stateful cluster, but we had to work around some of that challenges to be able to take the full power of AWS and the auto-scaling features, because once you have a stateful application, you can't really auto-scale, right? So we had to engineer some of the new methods to be able to achieve that auto-scaling. Some of the goals we wanted to achieve for this deployment, there's some business goals, and also we added some IT goals to accelerate the transformation we're doing at Rent-A-Center. So from a basic business goal, the site we had to build was to support 2 million users, right? That's our current activity. But it also had to scale to support Black Friday. And if not for a successful Black Friday, I wouldn't be here today. So last week, we had a pretty successful Black Friday because we were able to scale to that need. And another important or obvious factor for any e-commerce solution is PCI compliance and all the security requirements that go with it. HA is another one of those availability, high availability, including cross-region capability, are core components of the architecture. These are some of the core business goals. Then we added 2 other components to make part of the IT transformation is we used an agile development practice for rapid execution, and also we enabled code deployment at the Hybris layer without downtime. So we were able to do deployments during the day and be able to deliver value to the business faster and in a more agile way. So given the overview, I'll just hand it over to Arthur Suleiman, who can go into some of the more details, and then I'll come back and explain some of the outcomes and the conclusion.
Thanks, Hemant. Can you all hear me at the back? Okay, great. I just can't tell if the microphone is working until I hear my own voice, and I'm not hearing my own voice here for some reason. Okay, so as Hemant mentioned earlier, my name is Arthur Suleiman. I'm the CEO and one of the co-founders of a company by the name of Flex7. We are headquartered in Austin, Texas, and the focus of the company is to help organizations, the likes of Rent-A-Center, make that journey successfully into the world of DevOps. Our typical approach is to, we follow the switch theory, so the idea is to help the company create a center of excellence and create some bright spots, and from there, let the success stories by themselves kind of work as the ignition criteria that will allow other projects and other teams to jump on board. So the first bright spot, if you will, was the WAN project that Hemant talked about, which was the virtual acceptance now. And this was one of the key second projects, the e-commerce platform itself. The approach, just from a project management standpoint that we followed, was a 3-phase approach, which is what we typically follow. First, start with an architecture assessment. The goals are to understand the business requirements, understand the current technical state, design the state, and then create a sprint plan. I do want to speak a little bit about the sprint plan because this is a DevOps project. We are not doing development. We are not actually changing the code for SAP Hybris. However, as Hemant pointed out, there's the infrastructure as code. In addition to that, we have, as a part of this project, and as you will see later, security rules being embedded in there as code. We have the server configuration through Ansible and through Docker files also as code. So when all facets of your technology delivery are X as code, there is no reason to not follow all the best practices that have worked so well for the software industry for such a long time. So we use the agile development methodologies for developing infrastructure, security policies, and the server configuration. So that's why when we get to the implementation phase, the actual work happens as 2-week sprints. Another thing worth mentioning specific to this project on that methodology was that the development team, which was at Rent-A-Center, was also working under an agile methodology with 2-week sprints. And what we were able to do was basically align the 2 sprints so that the DevOps team was producing the underlying substrate while the development teams were producing the containers, if you will, that will run on top of the substrate. And I'll speak a little more to the details of the architecture here in a second. And lastly, the idea is to build the center of excellence. So there is a knowledge transfer back to the Rent-A-Center team so that they can take it from there. And the team has been fantastic, actually. In fact, a lot of the work we are doing here is stuff that I'll be talking about. I can barely take credit for a small fraction of it. It's mostly the work of the Rent-A-Center team in collaboration with some engineers from Flux 7. So from getting a little technical here, the big picture, there are some key components that form this architecture. As Hemant pointed out, high availability was a key thing, low management overhead, being able to put something together very quickly. All of that kind of points to one direction, which is we wanted to take advantage of managed services wherever we can. Rather than reinventing the wheel, take what's out there, take advantage of it, because it lowers the upfront cost, it lowers the ongoing cost. So you will actually see that we very heavily use some of the AWS services to make our job easier upfront and ongoing. The list is actually significantly longer than this, but some of the key ones here include the contemporary Lambda. We were using CloudFront as a CDN. We were using the AWS WAF, the ECS component, which is what makes this talk interesting to this audience, because there was a very heavy focus on containers. We have ECR, S3, and then we decided to use Amazon Aurora DB. So a lot of things going on. You're talking about an SAP Hybris application, which was written with a very traditional mindset, and bringing in a lot of these really contemporary technologies and blend the two to build an architecture that is high availability, auto-scalable, and has all of the things you would expect from a good architecture in the year 2016. So this is the diagram of our technical architecture. I'll start describing it more from the top left. So for the DNS, we were using Route 53. When the users had the DNS resolved, they would actually hit a CloudFront distribution. The idea was, and as an architecture that needs to be PCI audit ready, we have the AWS WAF in place that I'll deep dive into with how we actually use that in conjunction with Lambda to build the OWASP 10 checks that were happening on the fly. Some static assets being served out of S3, which has been a very traditional use for Amazon, so I won't dive too much into that. Getting into the more meaty and interesting stuff. So everything is inside a virtual private cloud, pretty much a given these days. We had a pair of public subnets and a pair of private subnets. This not drawn as a pair, but the note at the top kind of specifies that each one of these subnets that you see here really are 2 subnets, just assume in the 3rd dimension, to cover the multi-AZ aspect of things, and also means the fact that we're able to draw it like this, every single component that you see up there is multi-AZ. If an entire data center fails, we will still not require human intervention. Everything will continue to work. So again, following some best practices from a security standpoint, in the public subnet, there are no unmanaged services. It's just the load balancer and the Amazon NAT gateways. In the private subnet, that's where the more meaty stuff is, you'll actually see 4 components. One, there are 2 ECS clusters labeled storefront and admin, and we'll get into the details. But just to give you an idea, SAP Hybris has, you can say, 2 views. One is the user view. When you are a consumer, you hit an e-commerce website. If it's running on SAP Hybris, that's what you see. But then there's the admin view where people will log in, add new products, set up any configuration, generate any analytics. So that's the admin piece, and that's why you see 2 clusters. The user land and the kind of the admin land cluster. The ELB from the admin land was in the private subnet, only accessible from on-premise, which is to ensure that nobody from the outside can get to the admin interface. Now, behind that, backing all of this containerized environment up is an AWS Aurora DB. Again, just keep relating everything back to our business goals here: security, agility, scalability, high performance. And Aurora has all of that to offer, and that was why it was a choice for us. And I'll speak a little bit more to that decision and how we went about it in a second as well. In addition to that, I think one of my favorites, there's several other services in use, but one of my favorites is all the way at the bottom, the Cert Manager. So we went to the extent of using managed services and Amazon services that we did not even have an outside SSL vendor. Even the SSL certs were being generated by AWS Certificate Manager. Some of the other services and their roles at the top, we have PCI Tier 1 compliance. So there is need for some strong encryption, particularly around credentials and role separation. So we ensured that with, you can say, 2 levels of encryption. One is with our credentials. The credentials were being saved in an S3 bucket with server-side encryption enabled. But on top of that, we were using KMS to encrypt the stuff that was even put in S3. So even if somebody has access to the bucket, they needed access to the S3 bucket as well as have the IAM permissions to decrypt the files using the key management service from AWS. And the only entity that has that access are the containers that are running the production servers. Just some other Amazon services best practices include the use of CloudTrail, CloudFormation, so that's the infrastructure as code piece, using CloudWatch for monitoring. Simple email service was configured for email with SAP Hybris. We were taking advantage of code commit for particularly saving our infrastructure layer in AWS code commit itself. And lastly, just worth mentioning that there is that on-premise connectivity needed. It's a hybrid architecture. And what we had was direct connections back from on-premise. So just getting into a little more detail, I remember we had those 2, quickly going back, these 2 ECS clusters in our VPC. Well, that's what they look like internally. Both of them running a few Docker services, ECS services. The one at the top, you see Apache. We have SAP Hybris and a Solar service, a couple of Solar services, master-slave. In the admin, we just had SAP Hybris running. Remember that admin is just primarily for, you can say, content management, being able to log in and manage what the end user is going to see on the interface, so which is why we separated that out. The CI/CD layer is building up from, remember that Vendor Center, the situation is, we're actually kind of building up. We are on an evolution journey. The idea is not to go 0 to 60 overnight, but work with what we have and reuse what we have while introducing new concepts as we go. So what you see here is the code delivery pipeline. So from code deployment standpoint, we have the developers with code and Docker file being delivered into the SCM. And then there is Jenkins that will actually take care of building the containers. So it's worth noting this dotted line in the middle. What it's actually denoting is that to the left, what you see is the on-premise pieces, and to the right is what you see stuff that was in AWS. So what we have on-premise is our SCM and the build environment. That's the Jenkins that's in charge of building the container. The AWS side has another Jenkins, which is the deployment Jenkins. In addition to that, that's where the container registry lives under ECR. And we have the ECS services, the ECS component that is in charge of deploying our containers to the ECS nodes. I do want to highlight a little bit on why 2 Jenkins, and maybe I will speak first at a broader level than just this particular use case. And at Flux7, being a consulting company, we work with different use cases. It's actually come up more than once in the past where a customer wants to have the ability to use what they have in terms of Jenkins. There is a process, there is an on-premise Jenkins that is being managed by the release management team. It has been set up and vetted. And the idea is to leave the code and all of that process that exists today intact for two reasons. One, because the team does not want to manage two Jenkins, one in Amazon Jenkins and one an on-premise Jenkins. So keeping the build and some of the build test functionality in the same Jenkins as everything else is desirable. Has benefits as it makes the journey easy. At the same time, the jobs in Jenkins that are related to deploying on top of our production cluster, those are very Amazon specific. That has nothing to do with the legacy Jenkins, because the legacy Jenkins has been all about code, not about deploying infrastructure and not about updating services, say ECS services using CloudFormation in this case. The other factor is that the Amazon with IAM roles makes it really easy to deliver the correct credentials, the correct IAM credentials needed for that deploy Jenkins job to run. So what that all boils down to is we actually split the Jenkins. The deploy Jenkins uses IAM roles, uses all the Amazon goodies, if you will, and it actually stays in AWS, communicating as the gateway to the actual Amazon services that are responsible for deploying into production. The on-premise Jenkins stays there for reasons that is how it's being done right now and is a fine process. We don't want to open anything that doesn't need to be opened. So from that perspective, there's the two Jenkins here, the build and the deploy. So you can think of it as a security measure, a balance between what's there, what's the most secure way of doing it, and what leads to a clean architecture from a separation standpoint. Overall, so the deploy Jenkins, it's just to get into a little more detail, what it's really doing is under the hood, we have CloudFormation templates describing the ECS services. So when a new container is to be deployed, the CloudFormation stack used to create that service is updated, which has the ID of the new container image that triggers the ECS service update, which is done. So Jenkins triggers CloudFormation, which triggers the ECS update. And what ECS does is it actually informs the node that a new container image is available for a given service. ECS at that point, and ECS has this feature built in where we had it configured such that basically it starts replacing the old containers with the new image. So spin up a new container with the new image, take out the old one, then just keep repeating that process one container at a time, and that's where the final deployment is complete. So it's zero downtime deployment in the sense that we are basically replacing containers one at a time in a rolling fashion. I said earlier that code is just one of the components that you want to streamline the delivery of. There are other components, clearly, and any technology stack. Typically, we view them as 4 pillars, the 4 being code, being at the center of everything. But then you also have server configuration, you have infrastructure, you have security policies. So in this case, code and the server configuration is what was being delivered through that pipeline I showed you earlier. But in addition to that, there is a separate pipeline for delivery of infrastructure and some of the security practices that actually come baked into that. So they're all embodied inside CloudFormation templates. Infrastructure as code, so we are back to just the pipeline looking very much like it looks for any software project. So we have our DevOps teams that will push into the source control. That would trigger a Jenkins job. The Jenkins job will then run and update CloudFormation stack based on whatever update came into the version control system. And that would update the Amazon services intended to be updated. So you're getting built-in change management at this point, because any change to the infrastructure or the security components is getting logged into the SCM as it's being changed. And there is no way to make manual changes. The only way to update existing infrastructure is through this process. Looks very nice when your PCI auditor walks in, by the way, because you have a process and you have a process that cannot be circumvented easily and a process that's very easy to audit. So now let's get into the even more interesting and in-depth components of the architecture. So diving straight in, let's start with the Aurora DB component. So the goals with performance and scalability and high availability, we were looking for a solution, a database solution. Databases usually, unfortunately, are the graveyard of your DevOps and all that cool stuff that we talk about when we are talking about stateless components. And we were basically looking for something that could actually balance the two. While a traditional deployment of SAP Hybris, people would be looking at Oracle as the enterprise-grade database, we took a slightly different approach. SAP Hybris does come in with built-in support for MySQL. While MySQL may not be able to foot the bill for a website at this scale, we figured that we'll take Amazon Aurora for a spin, which was a brand new service and was MySQL compatible. And to our pleasant surprise, that process was incredibly easy to the point that it was seamless. All we had to do was spin up in our CloudFormation template an Aurora RDS cluster and point our SAP Hybris configuration file to the connection string provided by Aurora, and that's it, done. No code changes necessary, no discussion on whether or not this query is going to work, whether something is going to work. As promised, if you will, it is compatible or fully compatible with MySQL, and that was the experience. A very traditional application that is known to support MySQL just came up and lit up with no issues, straight on top of Aurora. So got us all the benefit with practically no effort, obviously a no-brainer decision. We have never looked back from there. The second component, so when you're dealing with PCI Tier 1, a web application firewall becomes a very important part of the strategy for OWASP checks, things like the common attack signature patterns that you want to detect and in fact block. So we decided then when it comes to WAF, there's different vendors and different choices available. In this case, we decided to keep it simple, and I put that in quotes because it's really simple once everything is up and running, and as I'll describe that. So rather than going with a third-party vendor, bringing yet another licensing structure, or procurement cycle, go with the AWS WAF. The way AWS WAF works, for those who have not used the product or are looking into the product, the idea is that it's a very flexible, it's kind of a filtering function or a rule engine, you can say. You have to write your rules, but once you have written your rules, you have a product that is setting inline, blocking requests for you, is auto-scaling, is high availability, and is pretty inexpensive compared to the other WAF solutions that are available. So the challenge is, how do I actually write the rules, and how do I get the rules in the right place? For that, AWS makes a set of functions available. So it's a multi-tier kind of a setup. The way it works is, and it's actually not just static rules, but you can actually create dynamic rules, which is what we ended up doing over here. So it's not like you log in there and I set up a bunch of rules. It's actually even more interesting than that. We actually wrote code that will create the rules on the fly as they were needed. So what that means is, I'll give you a concrete example. A single IP address has generated 500 requests in the last 10 seconds. Very likely that something is going on there because that's not a human being human being access pattern. So when the 500 accesses come in, the top red icon you see up there, that's AWS CloudFront. CloudFront is actually going to generate a log file with all the accesses that are coming in. So it generates a log file. The log file, it actually dumps it into AWS S3. Nothing special there. It's just a built-in feature. You just have to enable the logs. When the log file appears, at that point, it can be configured to trigger a Lambda function, which is exactly how we had it set up. So when the log file appeared, a Lambda function started running. The Lambda function analyzes the file, and based on that, create dynamic rules. So going back to my example, a malicious user is trying to hit our website 500 times in a short period of time and try to flood with traffic. The log gets developed. The Lambda function goes in and looks for those IP addresses that have appeared 500 times in the last 10 seconds. And if it finds any, it generates a new rule at the WAF, no traffic allowed from this IP address for the next 24 hours. Similarly, other examples, there's a couple of dozen of rules that we implemented this way. But just to give you one other example, for example, if a user is hitting unsupported or inaccessible URLs, so they're getting a lot of 404s, a single IP address is just generating a lot of traffic that is coming back with Web 404 errors. What does that mean? What that means is that the user is trying to basically find some kind of a URL that's hidden from the world, that they maybe find the /admin. If they know that this is SAP Hybris, they're going to look for the /admin, for instance. And it's going to lead to a 404 error. And if we actually detect that pattern, all of that does get captured in the logs. Log file gets generated. Lambda function looks for it, sees the attack signature, blocks that IP address, and keeps it blocked for a specified period of time. And in addition to that, there is a database of rogue IPs. The Lambda function also downloads that and keeps our WAF rules up to date. So it's a WAF. So a few things to note about that. It's a very flexible system. You can write any rule, create any rule that you want to create on the fly. Literally write it in terms of code, say Python, Node.js, whatever your favorite supported language by Lambda is. So it's a very flexible infrastructure. It kind of stays there. It's low cost, and once put in place, it really requires no human intervention. And it goes back to my point earlier, which is security rules are being specified as code because security rules have now turned into just these Lambda functions that can be delivered through a CI/CD pipeline and operate just like code, no difference from any of the best practices that we know work for software. Brings me to something else that's very interesting, which is this is an e-commerce platform. And any retailer, anyone who is doing any kind of e-commerce, very typical for these websites to have a need for auto-scaling because the traffic patterns are seasonal during the very different times of the day. And one of the things that we were looking for was the ability to auto-scale. Amazon has had support for auto-scaling for a very long time. In fact, they kind of coined the term, if you will, about 10 years ago with EC2 auto-scaling. However, when we are talking about container auto-scaling, it's a whole different beast. It's not the same as just scaling the number of EC2 instances that you're running. And in fact, there's two layers of it. The bottom layer, that's your number of EC2 instances on which your container cluster is running. And the top layer, that's how many containers I have running in a given service. So if I just scale the number of containers, what's going to happen? I'm going to run out of the underlying EC2 instances, and it's going to render my auto-scaling at the top layer irrelevant. Similarly, if I don't do anything about my container layer and I just have the underlying layer scaling up and scaling down, it doesn't really do anything useful because my users are never going to hit the actual VMs. They're actually dealing only with the container layer. What makes this problem even more interesting is that these two layers, if we are to plan to auto-scale them, they can't just be incoherently auto-scaling independently. What you don't want is the top layer deciding to say, I'm going to add more containers to my service, and the bottom layer deciding, I see some free EC2 instances. Let's actually start shrinking the size of the cluster. Similarly, vice versa, the bottom layer adding and the top layer removing. So they actually have to work in conjunction with each other. So while the essence of auto-scaling is the same as EC2 auto-scaling, the actual challenge is very, very different because it's two levels of auto-scaling that need to happen, and the two levels have to also be coordinated with each other. So what we built was a solution, again, using AWS Lambda, which is around basically the same principles on how EC2 autoscaling works. So the stats for the individual containers that are running on top of ECS are available in CloudWatch metrics. And you can read CloudWatch through an API. So we had a Lambda function that would read these stats about individual containers and use some simple rules to decide what the top layer scaling is going to look like. That is, how many containers do I need for, say, Apache? Or how many containers do I need for SAP Hybris? And it can scale up if the current containers are running too hot, or scale down if the current containers are running too cold. So while it's an interesting challenge in itself to solve, very similar to the EC2 auto-scaling, nothing groundbreaking there. The second piece was, how do we actually scale the underlying instances? So the traditional way of auto-scaling instances on EC2 have always been, let's look at the CPU. If the CPU average is over 80%, let's scale up, otherwise scale down. Or if it's below 60%, we scale down. That is not going to work here, because the top layer has to be taken into account when you are auto-scaling the number of instances. So for that, we actually had to devise an interesting algorithm, and my box is not showing very well here, but this pseudocode that you see in the middle is, the idea is that that's basically the Lambda function that runs. So what happens is, from the far left, we have the EC2 CloudWatch events triggering every 5 minutes this Lambda function. What this code is trying to do is basically query ECS using the API, looking at how many containers are needed for each one of our services. The idea is that we will find the maximum number of containers needed for a given service. But if that service decides to auto-scale, it is going to need at least one additional instance of EC2 underlying. So what we need to do is we need to say, if I have 4 services running, and let's say the 4 services have 2, 4, 3, and 2 containers running each, then the maximum number of containers I'm running concurrently is 4, because that's the service that actually has 4 containers running. So what we do is we actually keep 5 instances running, 1 more than the maximum number needed. What that does is it allows the top layer, the number of containers scaling, it allows it to scale whenever it needs 1 additional container. So it has that extra headroom that is available to it. However, when it does scale up, that means the extra headroom fills up. This Lambda function is going to run next time, and it's going to realize, oh, I only have 5 instances running, and there is a service using 5 containers. There is no headroom left. Time to expand my number of ECS nodes that exist in the cluster. So the idea is to keep, well, I'm using 1 just to simplify the example. The idea is to keep 1 additional ECS node available than the maximum number of containers being used by any service. In reality, what you're looking at is that 1 is being replaced here in the code with extra capacity. So we can tune that number to however much extra headroom we want to have, depending on the spike that we are expecting at that time. Just a little more detail, if you're interested in more detail along this line, we have actually open sourced the code for this, for the Lambda functions for scaling. And there was a blog posted on the AWS website a couple of weeks ago about this algorithm and how we actually achieved this auto-scaling. And the last piece I just want to talk about is that kind of where Hemant pointed out, SAP is not an application. It's not an application that was written in the year 2016 with containers and serverless, stateless, and all of that in mind. It's a more traditional application. In fact, to be fair, it will be fair to say that the application is in fact stateful in many of the ways in how it actually does things. So how did we actually implement it, A, inside containers, which are known to not play very nicely with that, and B, how do we actually implement auto-scaling on top of something like this? And keep in mind, there were no code changes made to the Hybris engine, so it's all done outside with the help of wrapper scripts and how we actually manage state. So I'll talk about perhaps the most interesting of our challenges that came up. So one of the questions is, Hybris, and when I say it's stateful, it's really built with the pet mentality. Anyone here not familiar with the pet versus cattle analogy? Assuming this is reInvent, so I don't have to explain that. Great. So it was written really with the pet mentality, where every node has a fixed IP address. I'm node, I need to know about all the other nodes. I just have a list of IP addresses of all the other nodes. That's option 1. The other option is, I have a node and there's other nodes running, and I can do a multicast to discover all the other nodes. Unfortunately, in our world, neither of those 2 options are available. Multicast is not available because AWS VPC networking does not support it. And the list of IPs is not available because who the hell knows what the list of IPs is? It's changing because of auto-scaling and all that stuff that's going on. So what we had to do was kind of go in deeper and look at some unconventional ways of doing this node discovery. And we actually found a relatively simple solution, which was that Hybris did actually have another mode that it could, in fact, what we could do was we could actually load the list of IP addresses of the other nodes. We can just load it on the fly, and they could be put in a database and can actually be loaded from there. So good, that's a pretty big achievement in that now we can actually, if we know the IP addresses of all our nodes, even if they are changing, if we can update our database with the updating IP addresses, the cluster will kind of figure itself out. However, this ran into an ECS limitation, which is how does the individual Hybris node know what its IP address is? Because if you say run and what is my IP, if you will, inside one of the ECS containers, the only thing you will get is here's the IP address of your container. By definition, a container is not allowed to know the IP address of its host. And that's what we are going to need for these containers to communicate. So basically started out with just putting an interim solution. We basically wrote a startup script with every container. And one of the things that it actually did was when the containers started, the script found out through some querying of the metadata on the EC2 instance, which luckily is available inside the container, to find out the IP address of its host, and then make that available to the Hybris application as part of a config file by just doing a find replace, if you will, on the config file. Simple engineering solution got us through, but a big shout out for a feature request to the ECS team here. If ECS supported a network overlay, where we could put all our containers in kind of an overlay network of Docker containers, we could, in fact, just use the Docker container IP itself for the containers to talk to each other. We had to jump through this hoop mainly because we were using the EC2 provided network. So a series of challenges, both technology-wise, and I only talked about the top few, but the good news is that we got it through, the project got done in time, and the system has been in production for a while. So I'll give it back to Hemant to talk about some of the outcomes and what they've seen from the business side.
Thank you, Arthur.
Sure.
So a lot of technical details, a lot of challenges that the teams had to overcome, but truly great shout out to a lot of engineering work that has gone on to make this work. So the business outcome we got as a part of this implementation was we are now able to get a 360-degree view of our customer base. That's a huge base, whether you go to a store or you go online. We want to be able to identify you, and that's the first step to get a unified view of our customers. Again, PCI Tier 1, that is a part of any e-commerce site, so we are ready for PCI audit when we undergo that. Availability, again, HA with multi-AZ, the architecture diagrams you saw did incorporate, even though you saw just one availability zone, everything is multi-AZ. And as usual, whenever as a part of our transformation, DevOps transformation I mentioned earlier, there's business outcomes and there's IT outcomes in terms of innovation, right? And that's what we want to do to help not only achieve the goals, but the goals are part of achieving business outcomes, right, to improve the agility. So infrastructure as code, agile and flexible infrastructure, and automated delivery of infrastructure. So going back to the most important points for any e-commerce website is PCI compliance and being able to achieve that. So we did incorporate a lot of best practices, including how AWS has a PCI total walkthrough on how to implement with a checklist and a best practices guide. So we did go through some of that to be able to help build our environment. And some of the key elements we used help us achieve that are the separation of accounts for prod and non-prod. There's also IAM roles we used, and the key encryption, which Arthur mentioned, which helps us encrypt all the database and other passwords that we need to enable for the application. Multi-VPC goes with the multiple accounts. VPC for your dev test is different from your production VPC. So from a security boundary and fencing, all that's baked in, right? So the most other important thing is, again, Atar went into some of the detailed challenges. It's very easy to put a one-liner there using WAF, but a lot of the things, we were one of the early users of WAF, Amazon WAF, and we had to build a lot of these rules, Lambda functions, to be able to help us achieve these goals. And as usual, we did use Ansible and Docker for a lot of the post-automation. And Docker also gives us that immutable infrastructure, right? So from a security, from a PCI compliance, there's not any way to get inside a Docker image, so that from a hacker perspective, that gives us that immutable requirement that we can satisfy. So we gave you a high-level overview, and I just wanted to summarize on various pieces that how we evolved in our journey using DevOps philosophies at Rent-A-Center. We started off, when we did the WAN project, Acceptance Now business unit, we started off using EC2 containers. That's our first project, right? Then we went through Docker. And the next evolution in 2017 is using serverless. So that is the transformative nature of how we do things, right? From a DevOps journey, we took the same steps. We first launched infrastructure as code. We did anything X as a service. So we are actually service providers to other parts of the IT organization. When we're giving logging as a service using our Elk stack, we're providing that as a service. And that's the first step into transforming how IT gets delivered. There's also CI/CD, which is a core component of enabling rapid execution and achieving business goals with incremental features and all the agile development practices that go with it. And this digital transformation we've enabled at Rent-A-Center has achieved us the business to achieve its goals, to meet competition faster, right? So if we put our customer hat on and it's all about the customer, and that the faster we help business achieve those goals, the better we are in satisfying our customers. That's all I have. Thank you very much. Any questions, you can feel free to ask.